Let me fix this.
Guys, I want to show you the whole thing again. I think seeing this, hearing this, hopefully will help. Here we go. Here is number 1. So, as always, when I'm trying to evaluate an expression like this, I'm always going to replace all the variables with empty parentheses. So my first step is going to be 4 minus blank times parentheses negative 4 times blank plus absolute value of 5 blank quantity squared times 3.
Oh, I didn't see the times 3.
Oh, got it. So guys,
I didn't see the times 3.
there's my first step. And yeah, the times 3 is kind of hanging out the back there. And so if you mess that up, you mess that up. But did you get the first step right as far as blank parentheses and showing good order of ops? I hope that follows. So then if x is negative 6, that goes here and there. And if y is 7, that goes there. Okay, so then I'm going to follow order of ops because I've got a lot of operations and a lot of parentheses going on. So this will be 4 minus negative 6, parentheses, negative 28, plus absolute value of negative 30, quantity squared, times 3. Continuing on with the work inside the parentheses, what's the absolute value of negative 30? 30. And then if you add that to negative 28, don't we get 2? Yep. Okay, so I'd get 4 minus negative 6, parentheses, 2 squared times 3. So at this point, I have done all the work in the parentheses. I've done that first according to PEMDAS. And now it is time for me to move on to exponents. I see the one exponent in there. Of course, it is a 2 squared. So this would be 4 minus negative 6 times 4 times 3. Now that I've cleared out all the work in the parentheses, I've cleared out all the exponents, I can now multiply or divide. I see some multiplications going on over there. So this is going to be 4 minus, what is negative 6 times positive 4? And then negative 24 times 3, negative 72?
Yes.
And that gives me 4 minus negative 72, which is really 4 plus positive 72. Looks like we're getting a final value of 76. 76.
When I added the times 3, I got 76. So
I did one thing wrong.
I feel like you did all of
You know, you did thing wrong.
Josh, did you forget the times 3?
Gotcha. Oh, man, he's still there. He's right there. There's Josh. Okay, guys, do you have any questions about number 1? It's like I like Josh's comment. Josh is usually really good at these things. His comment was, oh, man, I made one little mistake, right? Mm-hmm. And as you guys know, on these DMRs, since you get to practice them all week, one little mistake, that's enough to kill the whole question, right? One little mistake. And so as we work through the week, we want to refine this to the point where hopefully finally at the end we're like, I didn't make any little mistakes. I got that one right. That's the goal. It shouldn't be, well, that was pretty close, and pretty close, that's good enough. Not on a DMR. We need to nail it down solid, make sure that we're not making the even little mistakes. Okay, so then number 2. Did you guys all distribute first with the negative 3? Was that your strategy?
Yeah.
That's fine. Okay, so then if you do that, you end up with 9 is less than or equal to negative 3x plus 3, which is less than 15. I'm going to get rid of the plus 3 first. I'm going to remove any extra terms before I do anything else. So minus 3 from all 3 sides. That will give me 6 is less than or equal to negative 3x, which is less than 12. I will then divide by negative 3 on all 3 parts, giving me negative 2. But remember, whenever you divide by a negative, the inequality symbols have to get flipped around. So it would now be greater than or equal to x, which is greater than negative 4. All those inequalities got flipped around. This means my 2 key points are negative 4 and negative 2. What kind of a circle on negative 4? Open, and on negative 2? Closed. And then we connect the 2 of them. That would be my solution set, all the numbers within that. Did I mess something up?
No.
Okay. Question, Kyrie.
So
I did it a different way, but I got the same answer.
There is a different way to do it.
I divided by first.
Let's do that first. Maybe I'll get Joe's question real quick, or no?
I was just wondering how you write interval notation for something that has like two inequality signs.
Sure. So I would probably write this in the standard way. And then interval notation would be open on -4, closed on -2. Does that work? Okay. So Kyrie suggested maybe there was an alternative way of doing this, and I agree. So check this out. What if we came over here and we said we have the original, and Kyrie's suggestion was, couldn't we just divide first? And I think you can. What would you divide by?
-3.
So if you divide by -3 first, we'd have to divide everything through by -3. And this is kind of what you were trying to do. It's division, though. So then you'd get -3. But remember, we just divided by a negative, right? And so I'd have to flip my inequalities around. And I'd get this. And then my final step then, if I did it that way, would be what?
To add 1.
Yep. Add 1, and add 1. This gives me -2 greater than or equal to x, which is greater than or equal to -4. And it is, as you said, the same thing. That's good. Anybody else? Questions or concerns? Thanks for asking. Alrighty. So the number 3. Number 3 says graph it using slope-intercept form. It clearly is not in slope-intercept form right now. What would you guys do first if we were going to try to get there?
Subtract 4x.
Okay, so subtracting 4x, that would give us -5y equals -15 minus 4x. Final step.
Divide by.
That's right. So dividing by -5, this gives me y equals +3 plus 4/5 x. There are a lot of negatives, and I've seen a lot of people in the last month tell me that a negative divided by a negative is a negative, and that is false, right? Negative divided by negative is a positive. Okay, so my slope is 4/5, and my y-intercept is 0, 3, and so my graph would look roughly like this, and then I'd go, well, is there room to go up 4? I guess I could shorten my scale. Go 1, 2, 3, 4, and then write 5. Or I could go down 1, 3, 4, left 5, over about there. So then I would try to connect all those with a nice straight line, arrows on the end, and that's what I got. So does that go along with a positive slope? Does that make sense when you see the graph? Let me put it like this. A graph with a positive slope from left to right should go in what way? What pattern? Ooh. This is really, really bad. You should know the answer to this question. Yeah, if the line has a positive slope from left to right, the line should have what pattern? Uphill? Yeah, so if you picture a car traveling across your page like this, from left to right, when that car comes up to your line, it should go uphill if the slope is positive. If the slope were negative, that car would not be going uphill on your line, it would be going downhill. That make sense? Okay. All right, so guys, any questions on 1, 2, 3? 1, 2, 3. I'm going to erase those so I have a little more room for number 4. Now is your kind of your final chance to talk about 1, 2, or 3. All right, so then number 4 says solve using elimination. So if we're going to be doing elimination, don't we have to have the pattern of opposites? Do we have that? No, we don't, because the x's both have coefficients of +1, and the y's have coefficients of 8 and -4. Does anybody have a suggestion on how we could create the pattern of opposites? Callie?
I multiplied the bottom one by 2.
Sure. That makes sense, I think. So if we do that, we end up with 2x minus 8y equals 2. And now what I'm going to do, I'm going to add the top equation, the one highlighted in orange, to the blue equation, the one down there at the bottom we just made from Callie's suggestion. And now I'm going to add. So what is x plus 2x? 3x. What is positive 8y plus negative 8y?
0.
0. It's eliminated, right? That's why this is called
Elimination.
the elimination. The y's just got eliminated. That's right. equals 7 plus 2, which is 9. And so I divide by 3 to finish this. I get an x value of 3, and I'm done, right? No, I am not. What do I need to do? I need to find the y by plugging in. What do you guys think? Orange, blue, or white equation? Which would be the worst of the three? Worst choice.
Orange.
I think blue's the worst, right? Because the blue, the x has a coefficient, or
Yeah.
well, it's debatable.
I would do the orange.
I don't know, maybe that's not the worst
Depends
one.
on personal
They're all
preference.
fine.
I think it's debatable. Maybe it's really not the worst one. It's definitely a matter of opinion. So why don't we do the first one? If I use the first one here, I would say 3 plus 8y equals 7. Let's not do that, please. And I would just subtract by 3. I'd get 8y equals 4. I'd divide by 8. And I bet you this gave you a little bit of concern. You got a fraction for an answer, huh? To make anybody think, uh-oh, I messed up.
Yeah, I did all of them, and I was like, what?
Yeah, it's like you got 1/2 for all of them. Must be 1/2, right? So 3 comma 1/2 would be your solution for that system. It is where the two lines intersect. Makes both equations true. Questions on number 4? Okay. Fair enough. So you guys will get one more chance to practice this. That'll be tomorrow, and then Thursday should be our DMR quiz. All right. So as was discussed a little bit earlier, we did have a brief intro video on percent, and I would like to say that I think the topic we're going to be talking about today and tomorrow is probably the most immediately applicable thing we'll talk about this month, right? It's immediately could be applied, right? Percent is used and abused terribly all the time. Okay, so we're going to try to help you with that. On the video, we basically talked about what the word percent means and how you can write the percent as a decimal or a decimal as a percent, and they have the same meaning. They just have basically a different unit is what it comes down to. So what I thought we would do is talk about how we can work with some really basic non-contextual questions, and we'll finish out our class with some contextual, like it actually makes sense how it could be applied, right? That makes sense? Okay. So we worked on this for a long time. We continue to work on this, and you guys have made some pretty nice strides. We're going to be using the skill, the concept of translation. If you look up there, translate is one of our 10 first semester skills. We're going to try to use that skill to help us with percent in most cases, really. All right, so a couple of key words that you already know. We're going to use these a lot. What does the word is mean?
Equals.
It means equals. That's right. I'd say 99.9% of the time means equals. Or equal to, or equals, something like that. All right, what about the word of? What does of almost always mean? Multiplication or times, yes. Okay. So if you can get those two words' meanings really solid for you, then these really basic non-contextual examples, I'm really hoping are going to go super well for you. One little note. I am very much aware that there are other alternative ways of doing these. I get it. And they're all basically variations on what we're going to be doing here. So I'm not going to prescribe a certain method. What my line of thinking is simply, we've worked on translating. Let's make that work for us to make these as easy as possible. Okay, so number one says, what number is 28% of 39? And so as you approach a question like this, I would encourage you all to translate it. And I'm going to do this first one with you and show you how this could work, and then I'll have you guys try, maybe look at number 2 yourselves. So I see what number. In algebra, when I see some phrase like that, what number, what does that sound like to you? What number?
X.
It's an unknown, isn't it? And in algebra, we usually represent unknowns with variables like x. Or how about the letter n for number? That'd be another way you could do it. Y would be generic, kind of like x. You can really use any variable you want. It doesn't specify what this is. So I think maybe I'll use the letter n for what number? Is that okay? You could use x, doesn't matter. So n, what's the next word?
Is.
Oh, that's a huge key word. What does is mean? Equals. So n equals, And now we get to our first percent. Now, as we write these equations, we want to write any percents as literally what they mean. 28% written as a decimal is really what? That's right. So I'd write 0.28. And then I get to another word, and I think, whoa, that's another important word. Of means multiplication, so times. And then, of course, 39 is pretty easy to translate. So what I've done is I've taken that sentence, what number is 28% of 39? And literally, just like you could say, ¿Cómo estás? Which means, what, how are you doing? Yes? So you could say, ¿Cómo estás? You could say, how are you doing? They mean the same thing, but they sound different because one is spoken in one language, the other is spoken in a different language. That is the same concept. The first sentence was written in English. The other one was written in math. You need to think of it like that as simply a translation. Okay, so now would be probably a time to turn to the calculator. Our unknown number is equal to 0.28 times 39. Have you done that, Kyrie? What'd you get?
10.9.
Okay, so rounding to the nearest tenth, 10.9 does make sense. You guys okay with that number? 10.9. So calculators definitely be active on quizzes and tests having to do with this. I think having you do lots and lots of decimals is going to certainly add an excessive amount of time to your effort. Okay, questions on number 1? I'd like to see how you guys handle number 2. Please treat number 2 just like a translation. Don't overcomplicate it. Don't do silly stuff and overthink things. Simply translate it using the key words that we've discussed. Ready, go. I'm going to translate, just straight up translate. Obviously, the first thing I come to is a 52. That's not very hard to translate. We just write 52. The very next word I come to is the word is. Mariah, what on earth does is mean? Equals. 52 equals, okay? The next one, next piece of this, a little harder to translate. 120%. Faith, what do I do with that?
Oh, you change it to a decimal.
And it would be?
1.2.
It would be 1.2. That's right. So 52 equals 1.2. The next word I come to is of. What does of mean? Multiplication. So we're going to go times. And then I look at this last phrase here. What number in math, especially algebra, what number means some variable? We can go with x. It's fine. So we end up with this equation. All this is a straight up translation from that English sentence into this math sentence. This is a good thing to do. Good skill. Questions on my translation? All right. So then what I'm going to do is divide by 1.2 on both sides to get the x all by itself. And I'm guessing this has got to be that 43 number, right? 43.3. Okay, so 43.3 rounded to the nearest tenth is equal to x. Okay, questions or concerns? So I'd call these non-contextual, right? There's no real context for these. It's just, do you know how to translate and do a little bit of algebra? Basically it. So it's a useful skill. We'll get to the contextual stuff in a little bit. Okay, why don't you move on to number 3? Nobody's asking questions. So I'm going to assume that you can handle number 3. Please give that a shot. It's right there. Number 3, again, you could tell, like, take a quick peek. Some of you already looked at number 4. Can you see how number 4 is contextual? It's about a party and people. Number 3 is not. So this is the last of the non-contextual questions where you just have to translate. So as I look at number 3, obviously the first thing is really easy to translate. 7. And then it says is. What does is almost always mean, Nick?
Is equals to.
So equal to. And then I see these words. What percent? In algebra, when you see stuff like that, it's an unknown, and we represent it with what? And what variable did you guys choose?
N.
X or N?
I'm just using N, so.
P, Y, Z, whatever. W, whatever. What percent? Sure, that works for me. Let's go with W. I like it. So W, and then the word of almost always means times, and then 183. So please, again, let me encourage you in the strongest possible terms. if you have a tiny bit of struggle with these, even a little bit, you need to mark the question up. And you should definitely, from a structure perspective, in my opinion, follow a translation model, right? You're trying to translate over into English, or from English into math. All right, so then my final step would be dividing by 183. And I can tell this can be a pretty small decimal, right? Because 7 divided by 183 can be a small decimal. So when I do that, did anybody calculate this out? All right, I just want to know what 7 divided by 183 is.
3.8.
It's like
I don't think it's 3 point anything.
0.038. Yeah.
0.0383.
Yeah.
There's, but it's
0.0382.
Oh, wait, 825.
5.
Okay, so 3. Okay, fair enough. And this is equal to W. So this is where this one has a tricky finish, because if you look back at what this question asked, didn't it say 7 is what percent? In other words, what part of 100? I have not answered that question. I've given a decimal version of that. This is where that skill we talked about in the video is important. We need to move the decimal over. If we're going to have a percent, we need to move it over 2 places. So we'd end up with 3.8%. Please remember, percent simply means out of 100 or per 100. And so it's 3.8 parts out of 100, which same thing as 0.0383. This one asked for units. It said what percent. And I would encourage you to look at it like that. Sometimes we don't think of percent like that, but percent really is a unit. It's like square feet, cubic inches, miles, whatever it is. Just a unit. It just means out of 100. Okay. Questions on 1, 2, or 3? I'll have a lot of chances to kind of work through that. Okay. So then number 4 is our first contextual example, and I want to try to give you a modified strategy for this. We just have these last 2, I guess. So number 4 says 18 people showed up for the party. If this, I think that word "this" is pretty key. If this was 90% of those that were invited, how many were invited? What does the word "this" refer to? No. This.
18 people.
18 people. 18 people showed up for the party. If this, the 18 people showing up, so I'll put 18 people was 90% of those that were invited. How many were invited? So you could actually, it'd be challenging, but you could actually straight translate this. Let me explain. 18 people was. Was is really what?
Is.
Isn't it the past tense form of is?
Yes.
So I could look at this right here and say, wait a minute, was, that just means is. 90% is 0.9, right? Translate or convert it over to a decimal. Then look at that next word. Of. What does of mean? Times those that were invited. How many were invited? Isn't those that were invited, isn't that our unknown? So I don't know what letter you want to use. You could use the letter P for people, or N for number that were invited, I for invited, I don't know. T for those. Okay. I'm going to go with N or I'll go with P for number of people that were invited. You divide both sides by 0.9. And 18 divided by 0.9, is that 20? That's 20. Yeah. Okay. So 20 people were actually invited to the party and 18 showed up. So that's a straight translation. So I want to show you an alternative way to do this, because I think you'd have to admit that that was a tougher translation. Maybe this, and maybe I'm wrong. For some of you, I might be right. Maybe this would be better. Instead of like really working hard to translate one of these contextual examples, maybe we could think of these just a little bit differently. We can think of it like this. Part equals percent times whole. Part equals percent times whole. This is just another version of the whole of, is, multiply, equals thing, but it's maybe a little better adapted to these contextual examples where there's a story about people in a party And it's not always just so like dry like the whole of and is thing, right? Aiden, you with me? Okay. All right, so let's try to redo this one thinking about part equals percent times whole. What's the most easy thing to plug in?
18.
I disagree. I think there's something way clearer than that. 90%, right? So I would say right here I'll put 0.9 because it says 90% right there. That's pretty clear. Bless you.
Thank you.
Part. So it comes down to the 18, right? Is 18 part of the whole or is 18 the whole thing? I disagree. Wouldn't the whole thing be all of those that were invited? And wouldn't 18 just be the part that actually showed up?
Yes.
So I would say 18 is my part, my whole is my unknown. And once again, I would divide by 0.9. You can see I'd get the same thing. So I want to present you with a couple of different options, a couple of different ways to think about these. There's two of them at least, right? We good? Okay, so then let's take a look at the last one. I think the last one is probably the toughest. Here it is.
It's just a long problem.
But that can be challenging, right? Because you get through a word or two and you might be like, I give up. I don't feel like reading this anymore. It can be challenging for sure. So it says 45% of all Valor students support a change to the parking policy. If there are a total of 1,160 students at Valor, how many students do not support a change to the policy? I want to let you guys try this one a little bit, work through it, see how it goes. Check your answer in a couple of minutes. Although, wait a minute. When did our class start? 9:05? Okay, so I'll give you a couple minutes. So this says 45% of all students support a change to the parking policy. So we could do a little translation here. I see 45%. Do you?
Yeah.
As I write this down, I'm going to show you a couple ways to do this. As I write this down, I would write 0.45. What does the word of mean?
Times sign.
So I'm going to write times. And then I see this of all Valor students. Do I have any idea how many that is?
Yes.
I do, don't I, Joe? What is it?
1,160.
Yeah, there's a total of 1,160 students. That right there is how many students are at Valor, right? All Valor students, 1,160. So it'd be 1,160 is equal to, well, wouldn't this be the number of students that do support a change in policy? So it's a variable, X, S for students, D for do or something. I don't know, let's just use the letter X. You do a little arithmetic here. 0.45 times 1,160 is? 522. Okay. So then this right here, this is the number of students who support. Okay. So then that's not really answering the question. How would I figure then how many don't? I got to subtract from what? The total. So I'd go 1,160 minus the 522. You obviously do this on your calculator. It's 638?
Yeah.
638. So 638 students is the number who do not. Did anybody think of a faster way to do this? Because there is a faster way. It still uses some algebra steps. Check this out. Yeah, go ahead. Oh, that is so lovely, right? Because if 45% do support a change, wouldn't 55% not? So I think Jaden's idea of, hey, let's do 0.55 times 1160 is equal to our unknown. And that would probably give us 638, huh?
Yeah.
That was also a very good strategy. We had a little discussion there at the end. I know there was a lot of discussion about but, I've got the right answer. I get that. Make sure that you are showing algebraic steps like this one, like that one. You're showing a setup with an equation. This one had a pretty easy finish, right? All you had to do was use the calculator to do some calculating. Make sure that you are showing algebra steps. We'll keep working on this tomorrow.
Check it the other
Have a great day. Sure.
Check it.
Sure, totally.